So before we start solving these algebraically, let's first look at it graphically. So if I wanted to solve for when x squared plus 4x minus 5 is greater than or equal to 0, then I'm going to go ahead and plot that parabola, which I did over here on this graph. So as you can see, if I'm looking for what's greater than or equal to 0, I'm really looking at what is equal to or above this x-axis. So that would be this portion of the parabola and this portion of the parabola. And because of the equals to part right here, the greater than or equal to, I'm also including the points on the actual axis itself. So my answer to this would be x is from negative infinity until -1, and from 5 to infinity. We could also write it as an inequality where we have x such that x is less than or equal to -1, or x is greater than or equal to 5. If I wanted to graph this on a number line, then that could help you as well. Then we have -1, 0, 1, 2, 3, 4, +5. I would have a point on -1, and then we're going to the left, and then a point on 5 and going to the right. So all of these are good ways to talk about the answer. These two would be the correct ways to write it, and if they asked you to graph your answers on a number line, then we would do the second part right here. So let's solve this algebraically. If I have x squared minus 8x plus 12 is less than or equal to 0, the first thing I'm going to do is just figure out when is this equation equal to 0. And graphically, we're really thinking about when is this parabola crossing the x-axis. So I'm going to solve this just like we've learned before. I'm going to use factoring. So if I factor, I get x minus 6 and x minus 2, which means that x is equal to +6 and +2. Okay. So from here, I'm going to do what's called a sign chart. So I'm going to draw a little line graph and put 2 and 6. And the point of this is to figure out when are my values positive versus negative. So between 2 and 6, I can choose like 3. Something less than 2, 0 is always easy to plug in. And something greater than 6, let's do 10. So I'm plugging in over here just to figure out the sign. So you don't have to sit here and find every value. We're just trying to see if it's positive or negative. So if I plug in 0, I'm going to get a negative number here and a negative number here. Negative times negative is a positive overall. If I plug in 3, I'm going to get a negative in the first one, a positive in the second one. Negative times positive is negative. And then if I plug in 10, 10 minus 6 would give me a positive. 10 minus 2 is also a positive, so that will be positive overall. So if I'm trying to figure out when my equation is less than or equal to 0, then I'm looking for my negative answers. So this section right here. So the way I would write my answer would be x would be between 2 and 6, and I'm including both because it's equal to. You also could write it as 2 less than or equal to x less than or equal to 6. Both of these are acceptable answers. All right, let's try another one. And I'm actually going to change it and make it just greater than so we can look at a different type. All right, so the first thing I'm going to do is move all of my variables to one side of the equation because quadratics are a lot easier to solve when they're equal to 0. So we're going to move my x over and the 3 over. It's x plus 3. So we get 2x squared minus x minus 2 is greater than 0. Now we're going to follow the same steps as before. So I'm going to have 2x squared minus x minus 2 set it equal to 0. So we can figure out where it hits the x-axis. This one does not look easy to factor. I actually don't think it does factor. So I'm just going to use quadratic formula. You can use any method to solve. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So that comes out to 1 plus or minus 1 plus 16 over 4. So 1 plus or minus root 17 over 4. All right, so these are super ugly numbers, but no worries. We're still going to make our sign chart. I know 1 minus square root 17 is going to be on the left, and 1 plus square root 17 over 4 is going to be on the right. So if you aren't sure what numbers these are equivalent to, you can always put it in your calculator. But square root of 17 is bigger than 1, so 0 is going to be a number I could plug in. So I'm going to put 0 in. I'm going to plug in negative 10 and positive 10. Okay, so if we do that, and we can just plug it into the original this time since we have such ugly numbers. So plugging it over here. If I plug in negative 10, I get 2 times negative 10 squared plus 10 minus 2. So that's going to end up being positive. I don't even have to work it out, if you can see. If I plug in 0, I get negative 2, so negative. And if I plug in positive 10, that's still going to be like 200 minus 10 minus 2, so positive. So when I'm looking at when my equation is greater than 0 is going to happen when it's positive. So I'm looking at this section and this section. I'm not including equal to. So the way I would write this is x is from negative infinity to 1 minus square root 17 over 4, not including, and 1 plus square root 17 over 4 to infinity. Again, not including. We have parentheses. Or you can write it as x is less than 1 minus square root 17 over 4, and x is greater than 1 plus root 17 over 4. So gross numbers, but either way works. So in this video, we learned how to solve quadratic inequalities by using a graph, and then we took that concept and applied it to solving quadratics using algebra. Thanks for watching.